Hi everybody. Today we're going to look at least common multiples and how to use multiples to solve problems. Specifically, we're going to be looking at lowest common multiples to start with. And if we have two numbers 6 and 8, we can write out the multiples of 6 and the multiples of 8. And then we can look for a number that's common in both sets. In this case, it would be 24. And that's the lowest common multiple. And that's one way of finding a lowest common multiple. We're going to look at a different way today using prime factorization. So with prime factorization, we create products of primes. So in the case of 6, 2 and 3 are the factors that make up 6. In the case of 8, we can draw up a factor tree. And the factor tree to start with, we would look for a factor of 8, and an obvious factor of 8 is 2, because it's an even number. And then find out what it multiplies by. 2 by 4 makes 8. And since 4 is not a prime number, we split again, and we'll get 2 and 2. And the prime factors of 8 would be 2 times 2 times 2, all the bottom of the trees, and that's where this 2 to the power 3 comes from. Now, if we wanted to know the prime factors of both 6 and 8, what we would need to do is to look at the factors of 2 and write down the highest one. So in this case it's 2 to the power of 3 or 8, and look at the factors of 3 that are common to both sets. In this case that's the highest one because it's the only one, and then multiply them together. And if we multiply those two together, we get 24 as per what we did up here, but this time using an algorithm rather than just by inspection. So we can use this idea to find the least common multiple of the first 10 natural numbers. What we need to do is to find the prime factors of all the numbers up to 10. In this case it's 2, 3, 2 squared, 5, 2 and 3, 7, 2 to the power 3, 3 squared, and 2 and 5, and you'll find that all of these make the numbers on the left. Now once we've done that, we identify the highest power of 2, and that's 2 cubed from here. Then we would look for the highest power of 3, which is that one, put it here. 5, the highest power is just 1, and the same with 7. Multiply all those together and we would find the lowest common multiple of 1 to 10 is 2520. All of these numbers are factors of 2520 without remainder. Okay, first step done. So, and that was our first problem. Find the least common multiple of the first 10 natural numbers. Tick. I wrote the prime numbers down here just so I could remember them. All of these numbers only have factors of themselves and 1, and they're not composite numbers which would have more than 2 factors. So question 2, find the smallest number when divided by 3 gives a remainder of 1, when divided by 4 gives a remainder of 2, when divided by 5 gives a remainder of 3, and when divided by 6 gives a remainder of 4. And from that question we can see a few things. First, we're looking for a single number because it says find the smallest number. It's one number. The second thing, it may be close to a number that 3, 4, 5 and 6 divide into evenly. And the hint for that is that the difference between 3 and 1 is 2, and 4 and 2 is 2, and 5 and 3 is 2, and 6 and 4 is 2. So there's going to be a gap of 2. And that's what this last bit says. Now I'm not sure if it's going to be 2 more or 2 less, so I'm going to look at both cases and see if that's going to help me out. So the first thing we'll do is we'll find a number that all of these 3, 4, 5 and 6 go into evenly, and ignore the remainder problem for now. So the factors of 3 are 3, the prime factors of 4 are 2 squared, of 5 is 5, and of 6 is 2 and 3. I'm just thinking of factor pairs that make up these numbers here. It can be easier than using the tree method. And it's in fact how I did this. I thought, well, 2, what are the prime factors that multiply to make 2 is just 2, 3, 2 times 2, 2 times 3. Oh dear, I didn't sneeze after all, which is probably a good thing. So then I look at these and I say, all right, well, 2 squared is the highest power, and just 3 and 5, multiply those together and I get 60. Now if I test 60, it doesn't give me the remainders that the question's been asking for. So I'm going to try 58 and 62. So I tried 62 first, and when I divided it by 3 it gave me a remainder of 2, but according to the question I want a remainder of 1, so that's no good. So then I tried 58, it gave me a remainder of 1, and then when I divided by 4, it gave me a remainder of 2. When I divided by 5, it gave me a remainder of 3. When I divided by 6, it gave me a remainder of 4, as per the question. And thus, I was able to answer, find the smallest number with all of those criteria. Now, I've got a whole heap of questions for you to try that use this idea, and I'd like you to have a go at that before I see you next week. Thank you, everybody.